Hello everyone, let's get recording. My name is Aleksey. I work at Explode, which was called My Time a couple of weeks ago. We make a game platform about crypto games. We have a blockchain, oddly enough. Well, I've been programming for over a decade from now and reading a lot of code. And this my first time I've met you at these meetings. And you can ask, who doesn't program? Do not program. Do not read code, do not read lines of the code, and that's it. Okay. I have a perfectly live report, in fact, because I did not know with whom I would meet here, and that's why I did not try to complicate it. This will be a very simple and short report. I'll tell you about the thing called Tendermint, with which you can quickly do blockchain. Well, first thing first, not allow this to completely, since I did not know again who is who. I decided to start from some basics. Define the terms that we are talking about, because in fact, under these things, people have to understand completely different things. Some people understand by consensus only Satoshi consensus. Some understand mean only UTXO state. In general, about cryptocurrency, there are completely different opinions. First thing first, I will clarify the terms. It'll literally on 3 4 slides. Don't run away. The report's short, but I'll have time to drink. So, the obvious thing. What is state in my mind? I will emphasize this. State is a right convolution of all transactions applying the rule function. Who does not agree with this statement? All agree? Excellent, let's go further. What is cryptocurrency? Cryptocurrency adds value to transactions, and so this is a way to limit the bandwidth of our blockchain. Well, when a transaction has weight, blockchain's bandwidth decreases. The lower the transaction price, the higher the throughput. Who does not agree with this statement? Excellent. We'll discuss this later. Okay. And what is the consensus? Consensus is when we have several agents who want to come to some decision. Who will go to the vodka? But in our case, this is a decision about the state. So, what transactions to take in the state, so they're ready to roll them. What kind of consensus are there? It's a roof knife. I do not pretend to be truthful here. So there are Byzantine consensuses and non-Byzantine ones. Non-Byzantine consensus where we trust each other, where they not trust one another. Nobody wants to stay away from the work. And accordingly, we have Byzantine consensuses in which each pursues every agent, every actor pursues its own profit and wants to sway and not to go for vodka. And accordingly, the Byzantine consensus is divided into. It's possible to divide them so conditionally into classic Byzantine consensus and Nakamoto consensus, which was applied for the first time in Bitcoin. Well, the classic BFT consensus has a limit on the number of people who can participate in them. The complexity is growing. Nakamoto consensus has no such limit, no agents, actors, and accordingly we have a difference in the number of votes. The amount of voting power that is needed to conduct an attack on such a system. In the case of classical BFT consensus is 2/3. The case of Nakamoto consensus is 51% of the voting power. And that's all. We're on this finished. I hope we have defined the terms. So, what is Tendermint? Collecting from the terms, this is state machinery application, is a way to replicate the state with the help of the Byzantine consensus. But what does it include? This includes the system of distribution of transactions. Very first click here, sorry. Accordingly, the system of interaction of nodes, whether they are validators or not, consensus of validators, a system that finds a consensus between validators, and accordingly, the storage of blocks. This is what is included in Tendermint. But over Tendermint, you can already make your own blockchain. So, what will we have here? We have Tendermint, in which there is a consensus, a block storage, as what we saw, and we have some kind of our application with our rules, with our business logic. There's a business logic for our blockchain, in which there is transaction processing and our application state. This is what ultimately turns out. And they communicate with each other on gRPC. Those our network is a set of nodes that are associated with the help of Tendermint, and each has a node of logic in the form of some kind of written application. It is important to know that gRPC is a linguistic agnostic tool. We can develop this here as our application. We can develop it in any language, because Tendermint is a separate process that is not connected in any way and does not require any language feature. Therefore, we can write into Java, Go, Haskell, Node.js, any convenient language completely where gRPC is supported. Perhaps you have heard another name for gRPC. Well, some scheme out of it generates the source under the language, and accordingly, everything. You can work. Implement the interface, and this interface will be used by Tendermint in order accordingly to check the transactions. And takes the questions of the manner in which the choice of validators in such a blockchain occurs beyond the brackets. Well, by default we have some predefined list of validators. It can be generally 1, maybe 10, which will be the authorities in this network. If you want to do something more complicated, if you want to do their pause, or even POV, it will have to be programmed separately in the transaction logic. A few examples. The guys and their repository. By the way, I wanted to make a disclaimer that this is not our project, absolutely. These guys are doing out of space network. We just use their experience. So, the guys in the repository did such things as an example. They took their consensus engine and connected it to the virtual machine Ethereum. They got the project Tendermint. This is such a proof of third Ethereum. Very cool. Works perfectly well. It's not deployed anywhere, of course. It's like an example project. But for example, if you want, I don't know, to raise your own small proof of third Ethereum, for example, you can look at this project. Well, I was warned, so that there was no product pitch, so I just gave one slide. We're also developing our blockchain solution based on Tendermint. We are very satisfied, we did it very quickly. Accordingly, there is a node Tendermint, and our node There is a node Tendermint. There is our virtual machine and state, which we store in LevelDB. Source can be viewed. We made the first version, which is now laid out on the GitHub for 3 months. If you want to quickly make a proof of authority blockchain, Tendermint is an excellent choice. And I think we have time for questions. Excuse me? Can you repeat again? No. I do not follow the projects. I'm programming team. I follow only Tendermint separately. Tendermint are developing. They just released a new version. Quick development of blockchains with quick development of blockchain. Well, I don't know. Maybe I have an English curve. Thank you. Then the game's rewards crept in. I mislead all of them. Execute, you cannot pardon. The engine consensus? There is the question of a size of consensus. But obviously, if you make a consensus out of 1,000 people, he will not miss a single transaction for a second. We tested with 10, for example. Validators and empty transactions were... Well, 10 is not interesting. 50? What? 50 did not try. 10 have tried. Economically, 10,000 transactions are simply binary without validation, without any missing normally. In a second, yes. Well, binary. Just some random bytes. And the next question. And how many, again, what speeds does your database support the records in your chain? So, you use LevelDB. Well, LevelDB is fast. Well, it's clear, well, this LevelDB is just disk storage. This is not so important, in fact, because it will be clearly lower than... It will be clearly higher than the speed bandwidth of the network as a whole. Why you demonstrate such aggression? Well, this question does not interest me, so I did not measure it. I understood. In fact, you're in a stack in this case, in which the fact that LevelDB when it starts to slow down, you just stick to it. The moment it starts to break. Okay. I've just been using LevelDB for the last 7 years, and I've never had a problem with it. How many blocks did you put in LevelDB? As much as possible. What does the blocks have to do with this? I understand you're a programmer. You do not look, you are not a naturalist. Good, I understood. You have a negative experience. You can share it, read an article about it. I have no negative experience with LevelDB. Well, when I'm performing, I share. Good. Let's have another question. Look, you said the project Ethermint and what you can screw proof of stake. Well, in general. I understand any consensus algorithm. Did you get implementations from Ethermint with proof of stake and EVM script? And how much? How do you this? How do you do this? Well, obviously. Well, just like that, a simple measure will not do it. It is obvious to expand EVM under this business, so that it was possible. It should be understood that Ethermint assumes that the logic of choosing validators will be implemented within transactions, inside the transaction. Not somehow there at the network level, but inside the transaction. Wait, why inside? Would not the logic of choosing a validator be out of transaction? Tendermint does not imply this, as far as I understand architecture. Wait, how can the logic of choosing a validator be inside the virtual machine of this blockchain? Is not it happening outside? It seems on the other it's outside, and Bitcoin is outside in relation to the transaction. Yes, because both. On the other end, Bitcoin both. In principle, both can be done inside. Nobody hinders to make a transaction that will be checked whether the cryptographic puzzle is solved there or not solved. But honestly, did not read anything and did not investigate. But I don't see any obstacles to doing it inside. Well, yeah, the question was, did you come across an implementation and what do you think about it itself? No, I only looked at the Tendermint like this. As for example, it seemed to me interesting what they look as if combined. Well, it's just that both are written on Go, they do not integrate it through gRPC, but as it were, natively with the help of the Go-state models. Well, tell me, here is the poll solution. Here and now, on the basis of the poll, turn around and we estimate it all is an exceptionally temporary solution because it does not seem to decentralize properly. Because the question arises, who will this magical authority we give the community? And it seems the only normal way is to decentralize, there is to so oppose. Therefore the question is like on Ox2U. Why do you use the POW and how much do you have in industrial mode? As if using POW, but it's understandable. It's easy in the first place, secondly, we own the network. The first time to quickly develop, quickly to fork, not to have problems with the consensus between people, have a consensus within the company and simply translate the network into new versions until it becomes enough. Wow. And in general, after that it will make sense when this business decision is made. After that it will make sense to switch to some way of choosing a validator. It's not authority. Personally, I do not really believe in proof of stake. This is a topic for a super big conversation. I believe in proof of work and how I'm looking at adding to the transaction. So, there will be some special code that will check whether the cryptographic puzzle is resolved. And if there was a transaction where this puzzle was solved and the validators accepted this transaction because it is valid, the block, then by the rules, from the next block the oldest validator from the block is out and from the list of validators comes out. And a new one that decided the puzzle is came to the list of validators. So we have rotation. Yes, it's rotation. And it turns out in POV and like BFT at the same time. We have the advantage of both and difference sits simply. But tell me, did you basically implement your own set of comments and the architecture inside the blockchain, this blockchain? Can you talk about it? This is for what and for there, but again, I was told that there was no need for the product pitch, so I made a report about Tendermint, not about the truth. Well, it's an applied application. Why did you need to create your own architecture blockchain, for example? What do you put there? Well, in general, I want to have technology control. There are well some at the other. In my opinion, again, it's perfect. We can argue about this. There are both drama. For example, the guys did as it were crypto-anarchist. As if in accordance with the precepts of Nika Saba, they made smart contracts viable. For this now, because of the fact that smart contracts are the most effective, Ethereum developers make these 3 unified smart contracts. When there are databases, there is a front end, there, and economically the implementation of the contract. Well, it works. But it seems to me like a crutch. I want, for example, mutable quotation marks contracts. They cannot be called contracts because they're mutable. We call them programs. Within programs or smart programs within the team. And yes, this is very convenient when the program is mutable. I would like, for example, to support fleets of deterministic doubles. For example, on the other, As I understand again why it's not done, no one writes about it anywhere, but my understanding is that since the ether is written, the reference implementation of the ether is written on Go, and fleets are calculated on the processor on which it always calculates the fleets using a microcode of particular processor. But as you know, it can be different. And in GVM, we have a GVM application. There is a string PHP. There's soft and the implementation of double seconding to the standard. I think it's ERC 721. I could be wrong. It really works deterministically in a currency standards. We have normal fleets. Well, a lot of little things. Many little things that I would like to have. Why not use WebAssembly, for example? How would WebAssembly? Well, this is already outside the report. This is beyond the report I can try to answer. There is a program, for example, on C, which is collected via WebAssembly in the WebAssembly bytecode. In this program, there is, for example, it's compiled along with some kind of memory allocator. And this memory allocator, where should it be? Is it supposed to be right inside this program, which will be put into the blockchain? How to do dynamic linking with WebAssembly? Here is no calculator for this, and I don't really know WebAssembly but the number. I guess it myself a list of questions like this. What does dead code elimination do there? How to do dynamic linking with dead code elimination, that in general there is a separate special Olympics game. And how would I Google it? Well, on the forums read, well, but now to WebAssembly, everything will be cool. And I have such a fear that the programs of WebAssembly will, wait on, I don't know, on 300 kilobytes. Maybe I'm wrong. Thank you. There is no more questions? Thank you. Thank you very much, Aleksey.